Distinguished guests, thank you for coming for the fourth session of this wonderful symposium. This session will focus on industry-university collaboration in circularity. And I'm Burak Pak, I'll be the moderator. And we'll have four presenters for the session. Justo Garcia Navarro, Mustafa Şahmaran, and Ricardo Rodriguez. So Jean Sheriffol will not be able to join because of her sickness. So we'll move on to Professor Justo Garcia Navarro from University Politécnica de Madrid. It's an online presentation.
So let me share with you my presentation. I was asked by Professor Çogakoglu to give you a short view about the things we are doing within the framework of the ELISA Alliance and also inside of our community related to the circular economy. So this is the reason of the title of my presentation, which is the new postgraduate programs in the context of the ELISA Alliance of Universities, objectives, pilot projects, and reference to follow. I was just talking with Professor Çogakoglu to be sure how familiar is the audience with these issues related to the ELISA Alliance. She said to me that I can make a short overview about what are we doing with this Alliance of Universities. And this is then the index of my presentation. I will talk about the Alliance, about our community, Circular ELISA community. I don't want to make a talk about circular economy because, of course, you are having a lot of speakers giving you a very interesting view from the technological perspective. But anyway, I will use the circular economy as a break in my presentation. And then I will arrive to the context of the European higher education area and the projects ongoing within the ELISA framework. Yes, as you should know, Istanbul Technical University and also my university, Universidad Politécnica de Madrid, are both part of the ELISA Alliance of Universities, where we are 10th European high-level universities working together with the goal of having a common framework of working, teaching and learning, and trying to develop a new model of European engineering, which is one of the goals of the European community. This ELISA Alliance has its name because, yes, this acronym is coming from this long name, European Engineering, Learning, Innovation and Science Alliance. But also it's given a kind of tribute. Sorry about that. I jumped one of the slides. Is because we are giving a tribute to one of the first ELISA, engineering woman in the world, which was Elisa Leonida Sanfirescu, and especially because she embodied also the core elements of the ELISA Alliance, having a multicultural and cross-border background, contributing to the engineering with innovative methods, and having a determined social commitment. So I will share now with you a very short video to present the ELISA Alliance.
Dear Laura, by the time you read this, it will be the year 2030. A year in which all people have equal opportunities, access to food, clean water and energy. We are all healthy and thousands of species on our planet are saved from extinction. That is what some grown-ups say. But today, almost 10 years apart, I wonder how we can accomplish that. My mom says there is a good chance to make it happen. If we all learn how to take the green path to a more sustainable way of living. If we embrace the know-how of experts, students, teachers, and society, and we connect it to real people's needs. If we mix disciplines, people, and ideas, we design technology and combine resources to solve challenges with love and creativity. If people go beyond borders to learn and work in cooperation with others, celebrating diversity and inclusiveness. My mom is a scientist and says
all these transformations have started, and I want to be part of it. That is why I will study to become an engineer in 2030. An ELISA engineer.
Well, this is a very nice presentation about the aims and goals of the ELISA Alliance. This is what we are deeply involved in the development of this new model of university, of this new model of European university. And you are a brief explanation as well on our mission, vision, challenges, people, activities, and evaluation. The idea, as you can see, is to give an added value to the way that we all are using to teach our students, to base our challenge on the SDGs, and to work in using interdisciplinary and diverse working groups with all the agents involved, teachers, students, NGO experts, public institutions, etc., making engaging activities that can be evaluated using criteria, recognizing students' engagement, and giving them what we call an ELISA credential with digital budget that can be also added to the personal curricula of each of the students. This is the map of the universities forming part of the ELISA Alliance. And let me also explain that in the same way that universities are based on centers for the administrative activities, and also based on departments for the academic purposes, the ELISA Alliance is based on communities. So communities are multidisciplinary international teams working together to foster engineering research and innovation, and, as I said, finding sustainable solutions to real-world challenges. We, Professor Çolakoglu and myself, and also a very long list of researchers and professors, are part of the ELISA circular community. We define our mission to develop resources for promoting the incorporation of a mindset that favors the transition to the circular economy, addressing the social citizenship and sustainable competencies of our future professionals. I can also present you a very short video explaining what we are doing. And at this moment, we are componing this circular community, 5 of the 10 partners of the ELISA Alliance. We are the Turkish colleagues, the Romanian, Italian, French, and the Spanish universities forming part of this community around circular economy. Here you are, this video presentation of our community. I will try to share with you now.
A community of the ELISA Alliance of Universities around Circular Economy. University partners: Politehnica University of Bucharesti, Santana School of Advanced Studies, Polytechnic University of Madrid, Istanbul Technical University, and external partners from diverse industrial sectors. We are here to promote a mindset that favors the transition to a circular economy, developing resources, social citizenship and sustainability competencies to address the challenges of the future. Our vision is recognize our social responsibility and build a common vision of the strategic role of higher education in meeting the challenges of the UN Sustainable Development Goals. The ELISA Alliance is an opportunity to join forces with the objective of developing resources to better understand the circular economy and its role within social citizenship and sustainability competencies. In collaborating with professors, students and researchers. Activities we do in Circular ELISA community. Seminars, workshops and webinars. Seminars focus on participation, shared ideas and knowledge acquired. In the workshops, teamwork, brainstorming and infographics are developed. In the webinar we talk about sustainability, shared value and society.
Well, this is as I said, a brief resume of what we are doing. You have now in the screen a summary of some of the last activities where we were involved. Let me highlight some of them. The first one is this very interesting workshop organized together with Istanbul Technical University and Universidad Politécnica de Madrid. We were working around the disasters you unfortunately had some months ago, trying to introduce AI vision or AI resources to work and to try to retrofit and restructuring the areas post-disaster. And also, let me also show to you this sustainable design thinking pilot we did in Paris in the beginning of September as one of the examples. The reason I understand that the main reason that I am here in this symposium is because we had also another event in the beginning of July, so before the summer, inviting professors and researchers of all of the ELISA partners, but also some other people from external universities, trying to define new projects, new proposals for the following year. And this is where we start thinking on a proposal on developing joint programs around circularity, around circular economy. And this is what I'm going to show you in a minute. As I said, I don't want to go to this technical aspect. You know a lot about circular economy, so it's just a way of interacting with you. So I will go to the summary of these principles of the circular economy. You know that we are based on a design out of waste and pollution, the goal of regenerate natural system and to keep products and materials always in use, always in the chain of use. So we are arriving with this concept to the European higher education area and context, and to jump all of this text that of course you cannot read. Let me say that the European Parliament and also the European Community agree on a very important idea related to the European universities, European institution, is that which is that we need to adopt a single approach. We need to have a unique approach to this area of education, and this is why we are now on the discussion of what are they expecting from us. We have a lot of offers proposing double degrees. It's not the same that a joint degree. A joint degree would give rise to a single and unique degree from the institutions involved, and a double degree would result in 2 degrees, which apparently for the students is something better, because at least they will have a double diploma, 2 titles. This is the common practice in Europe, but this is because it's the format that we all are using in case where there are legal or regulatory reasons why a single degree is not possible for one of the institutions involved in the project. So, as explained, when double degree is because generally 2 universities or more universities agree to combine and study 2 study plans, where each university teaching only part of the program and recognize the rest to the students that are following this rest part in one of the universities forming part of the agreement. And with a joint degree, the syllabus will be the same for all the universities, and the students can complete the program by following any of the courses, subjects in any of the universities that are part of the agreement under the mobility rules of the program. So apparently is less than the first we were talking about, the double degree, because it's only 1 title, but it is the strongest way of teaching and learning, absolutely open to the students to stay where they and the moment where they select and in the university they prefer during the whole program. So this is what this is why the European goal is the joint degree. Of course, the difficulties now are much greater to develop this type of program, but we are now looking at this, and here you are the model we are trying to develop inside the ELISA framework, and with the help and with the contribution of the Circular ELISA community professors and researchers. We are trying to develop a joint master degree in circular economy and to complete this long pathway with a joint PhD program in circular economy. At this moment, we are working together, Istanbul Technical University, the Technical University of Bucharest in Romania, and the Universidad Politécnica de Madrid from Spain. We are just starting. Let me show you some examples to follow, because we have not very much, but very nice ongoing programs where we are focusing. ELISA Alliance had the opportunity of presenting one of the first programs in this way.
Time is running out, so quickly concludes. Thank you very much. Sorry for bothering you, Professor.
Okay, no problem. 1 minute more. So we are working following the idea of the digital twins master degree, which is one promoted by the 5 ELISA partners. You all should know about that because this Istanbul Technical University is one of them. So the idea is a 60 ECTS program with 20 for basic skill modules, 20 for digital twins technologies, and the rest related to individual thesis at the end of the master. And the other program we are looking at is an European master degree called Advanced Materials Innovative Recycling, especially because it is very well connected with our community around circular economy, and also because we, Universidad Politécnica de Madrid, are part of the 6 university partners of this program. We are also an Erasmus Mundus joint master degree. We are offering 6 different pathways combining 3 Master 1 universities and 3 Master 2 universities. This is the way of combining the pathways. And yes, because I've been asked to finalize my presentation, and because you are going to have this information, because I understand that the documents will be shared with you. This is the end of my presentation. I will be here with you until the end of the session for any questions you can propose or any that can arise to your mind. Thank you.
Now, I'd like to quickly get Mustafa Şahmaran from Hacettepe University to make his presentation.
Mustafa Şahmaran, during this time, I will start to introduce myself. I'm working as a faculty in the Department of Civil Engineering at Hacettepe University. Today, I will talk about the transition of earthquake disaster risk into circular economy in the environment. As you all know, the construction industry is one of the largest sectors globally and is constantly growing as a result of the activities such as population growth or urbanization or immigration. However, the extraction of the raw material for the production of building materials and intensive use of the energy brings some environmental and health issues as a result of the construction activities. For example, just during the production of a ton of cement, almost a ton of the carbon dioxide emissions will be produced, and also for the production of 1 ton of the Portland cement, we need around 1.7 ton of raw materials, which are clay and limestone. And as a result of these activities, a significant amount of construction and demolition waste is generated. For example, as a result of the maintenance, repair, demolition of the buildings, and their direct discharge to landfills cause a great damage to both the environment and the economy. So here we can see some of the data about the amount of demolition waste produced in the world and in European countries. Unfortunately, the random disposal of the construction and demolition waste is a major environmental threat. At the same time, not reusing of these materials is contrary to the concept of the circular economy. We can see from these graphs the amount of construction and demolition waste generated worldwide, which reached billions of tons in the current situation. So today I would like to mention some of the recent best environmental practices that we have conducted in our campus in Hacettepe University. So we completed several projects, but I just want to summarize 2 or 3 of them during this presentation, which are related about the valorization of the different construction and demolition waste products. In this context, one of our projects with real case studies titled a legal construction system of green structural components for low-cost housing, which supported with the government of Turkey and the UK. In this project, our ultimate goal was to develop alternative building methods to Portland cement concrete by geocompensation of the construction and demolition waste. And our objectives is to use only waste method in the production of these new generation we call green concrete. And in the first phase of the project, we collected a construction and demolition waste separately from a demolition site and subjected it to a crushing and grinding process, on a very simple process, crushing and grinding. And according to findings of our preliminary studies, we realized that the physical and the chemical properties of these wastes may vary from one location to another location. For example, we characterized the waste collected from the 7 different regions of our country to guarantee that the recipes that we will develop perform similarly regardless where they are collected. And according to the results that we obtained, initial results, I can say that all wastes, regardless of their type, origin, can exhibit similar performance as a result of the local optimization of the mixture. And in the next step, as a second step of our projects, we put effort into the development of Lego-type demountable structural elements, which have significant time and cost advantage in terms of the molding, workmanship, and structural stability. These are the main problems, especially in the volcanic regions, current main problems. And these elements, which we produce with the geopolymer concrete, has all structural tests, including severe earthquake loading. And after, when we complete the initial projects, as the second project, which is the continuation of the first projects, in this time, in addition to the production that we developed, different kind of the green concrete recipes, we have started to capture carbon dioxide in the structure of the waste material, in the structure of the demolition waste. And our objective is to further improve the quality of the construction and demolition waste. For example, not only capturing the carbon dioxide in the structure of the waste materials, but also our objective is to improve the quality of the waste, for example, by reducing the water absorption capacity. Here's some summary of our initial results. What we found, we installed, what we did at first, we installed a carbonation reactor in our laboratory for the carbon capture of the construction and demolition waste. From the steam gas, we tried to stimulate the steam gas coming from the Portland cement factory. And after the carbonation process, we have significantly improved in many properties of the construction and demolition waste, such as water absorption, the compressive strength of the metals which were produced by using this waste material, and workability. In addition, by successfully capturing and storing around more than 150 kilograms per ton of the waste material, with the price less than $30. This is the price much more lower than the price per ton of the carbon dioxide as a result of the carbon tax, which is in the level of around $100. And we measured many environmental impacts such as global warming, climate change, toxicity, energy consumption of the products we developed for a large-scale manufacturing carbon field demonstration through its entire life cycle with some kind of life cycle analysis. Our study shows that 100% construction and demolition waste-based green company have significant environmental advantage over conventional cement. Okay.
What if the strong concrete house
Moving. Let's watch together.
you have built can be demountable? According to a new United Nations report, the world population is expected to reach 9.8 billion in 2050 and 11.2 billion in 2100. This will increase the demand for new constructions, which will require more raw materials. On the other hand, when the service life of a building ends, an incredible amount of solid waste is created after the building is demolished. And now, the construction demolition waste becomes a larger and larger problem each day. We use different techniques to mainly utilize construction demolition wastes as recycled aggregate and filler materials in traditional concrete, or binding materials in geopolymer concrete. The recycled materials were first crushed, then separated into two main categories: a very fine material for the hydration reaction and a recycled aggregate material. After that, the recycled materials are mixed with a sodium hydroxide and sodium silicate solutions to produce the geopolymer concrete. We also developed a special reactor to bind the carbon dioxide to the recycled aggregate. This carbonation reactor was designed to increase efficiency of carbonation of recycled aggregate and demonstrate a real-scale prototype for the next stages. Column-to-foundation connection, beam-to-column connection, and slab-to-beam connection should exist. This Lego-type construction aimed at developing necessary details for fully demountable CDW-based construction to take a big step in sustainable construction. A variety of alternatives for column-to-foundation connection was developed. To gain the ability of fully demountable construction, the damage at the ultimate stage should be accumulated inside the column element, not in the connection. This is our performance limitation in the design of all connections. Testing is essential to determine whether the performance objective is met or not. If an extraordinary practice was tried to be accomplished, failure can be inevitable. After several modifications, we were able to meet the performance objective, and no damage accumulation in the connection was observed, followed by a significant ductility of the geopolymer column. The better news is the performance of the geopolymer column is similar to the conventional concrete column. But now, a new challenge is to connect the columns to beams to form a vertical load-carrying system. As usual, we need more than one alternative. The beam-to-column connection has two components: column cap and beam end detail. This scene is taken from a test of a fully demountable beam-to-column connection. Tests are completed. It is time for full-size production of the elements. This production was made in a precast concrete plant, where 24 columns, 37 beams, and 19 slabs were cast in the course of 1 month. This project is a perfect example of an integrated joint project, which makes it deserve a real-life site implementation that will be one of the foundations for new circular concrete applications. For this purpose, a prototype building was planned to be constructed in Ankara, Turkey. The site was selected within the campus of Beytepe, Hacettepe University, among the forest of Beytepe. So it will be in harmony with the green concept of this project, where eco-friendly geopolymer concrete with 100% construction demolition wastes was used. We started first with the foundation of the building. At the same time, the production of the demountable structural elements has started in the precast plant. By the day that the elements and the foundation reach the design strength, the elements were transported to the work site. The construction started with vertical structural elements. Then, the columns were erected to their vertical positions, placed on base plates, and bolted to maintain their aligned positions. All demountable column elements were installed in less than 3 hours. Then, the beams were transferred to the site and placed between every 2 columns by simply sliding them through the beam-to-column connections. This operation was also a smooth one, and it took less than 3 hours. It should be noted that the columns and beams were produced with relatively large sizes, so it allows future uses in multi-story buildings. The structural system of the prototype building was finally completed by placing the slab elements on top of the beams. A black membrane was placed between the slab and the beam to fill any manufacturing spaces. This operation was also easy to apply, and the whole construction operation was finished in the course of 2 days. Besides the structural elements, the walls of this building were also made of precast panels, so the building can be fully demountable. The panels were also mounted with the help of a mobile crane, and each panel took a time around 15 minutes on average to be installed. This stage took also about 2 days to finish. And finally, we have our first fully demountable green building ready for the final stage of finishing construction work, then to be put in service.
So we are currently updating these buildings in the campus of the project, but I would like to make my best. But the first speaker has already didn't do this speech, so I can use okay. During the production of these wall elements, we will need a collaboration together with the Metropark. And now, currently we are constructing a new village in Malatya by using these waste materials obtained from the volcano. And in these structures, we started to develop a different techniques. This is one of the buildings developed by the Ministry of Environment, Organization and Climate Change. With the experience that we received from the previous projects, we started to construct this village. But in this time, there is one short video, but I'm going to show all of it. In this video, you can see the construction of these new buildings. But different from the first one, in this case, what we the first time in the world we are producing remarkable and greatest foundation in this case. Hopefully, at the end of the day, we will be completed with one village. So I just want to skip this one. So as a result, before me, that she has already made presentation and she mentioned about the iceberg projects. We are one of the partners in this project, and we developed several different kinds of the structure, construction methods and structure elements. You can see some of them in this picture. So one another application, we are also working on the geopolymer and conventional concrete for the 3D printing. We have made a lot of very good progress on this topic, and hopefully we have already completed one with the size of 50 meters square, but just we need to complete the roof part of the structure. Hopefully at the end of these months, this structure will also be ready. In my final slides, I just want to mention about the earthquake as you know from on February 2023. 2 earthquakes with magnitude of 7.7 and 7.6 occurred, and 2 major earthquakes caused damage in an area of approximately 350,000 meters square. So this means that almost 14% of the total population of the Turkey is affected as a result of this earthquake. Unfortunately, the material and the moral damage and loss of life of the earthquake has severely affected our country. And investigations on the construction side of the earthquake showed that approximately 200 million tons of the earthquake was generated. These mixed earthquakes include some kind of the concrete, stone, tiles, bricks, glass, plastics, leaves, and different kind of the waste material. And now we know that with the experience and with the development in the construction materials industry, by separating these wastes, it's very easy. We have this kind of experience as a country. They will be related in the construction industry and will provide a significant economic and environment effects. I just want to show, for example, one table of data from the new Senate specification. It was published in February 2023, just 3 months or 2 months ago. This is the new specifications, cement recycled building materials. In this specification, now we have a chance to use these concrete levels up to 35% in the production of Portland cement. So it is permitted to use it. So there are some characterization of the waste that we have collected from the demolition area, and we can see that most of the chemical physical properties can be suitable for the production of these new cements. So in conclusion, I would like to summarize. Recent earthquake generated more than 200 million tons of the earthquake waste, and we have a good experience in knowledge of in the recycling of these separated construction demolition waste material. And what we need to do at first, we need to separate these waste material. There are lots of very good experience from the past for the separation of these waste material. In Turkey, sorting and separation technology is also very well developed. And if these waste materials are separated, they can easily replace with the existing raw materials up to 100%. So thank you.
Thank Professor Şahmaran for his nice presentation, animated video, and a wonderful session. So we continue to end this session with Ricardo and Rodriguez, and he will be joining online.
Thank you for the invitation to the Istanbul Technical University and to ITU Circular and Built Environment Research Group. I will present to you the circular futures approach. This is the topics that I did my PhD on at Edinburgh Napier University. And this approach is not just my work in isolation, but I would like to thank Francesco Pomponi and Bernardino De Amico, my director of studies, and then experts on circular economy, Ken Webster, Patricia Guicciolini, and Julia Viero, and foresight experts, in particular, Tanja Schindler, Graciela Guadarrama, and Carla Paniagua. Very briefly, I want to share with you who am I right now after finalizing my PhD. So I'm working as a principal in circular economy at Ramboll in the UK. Ramboll is a consultancy company with presence in more than 40 countries. And I'm an experienced professional with over 12 years of experience in sustainability and circular economy, both from the private sector and from academia. I used to work at Heineken Mexico for over 10 years, and I developed the current circular economy strategy, a 3-year strategy that we build around circular economy. I finished last year my PhD in circular economy and foresight, and I will explain in the next slide what do I mean by that. And the approach that I will present, it's applied to organizations, but the approach is built in a way that I hope it will be also applicable to you. And I'm also keen on contributing still in academia. So I recently contributed with the University of Chicago on developing an executive course in circular economy and sustainable businesses. And I also collaborated with the first online course for Latin America, so a circular economy course in Spanish. I'm from Mexico, and that's also one of the reasons. So let me give you a little bit of context on why the circular futures approach is relevant. And the reason are that we live in an unpredictable world. And this means that the economic changes and the pace of change are never as fast as today. But at the same time, we have a growing number of problems considered wicked problems. And wicked problems are problems that are systems problem. And when you think that you already solved it, then a new challenge appears. And finally, we live in a world that is known as, because of the acronym, a VUCA world, which means that it's vulnerable, uncertain, complex, and ambiguous. So the demands of customers and also our inner desires are usually to think holistically and also to make profound decisions. So these are 21st century issues to consider. Considering this, I want you to reflect on the type of futures that we are getting. And I really like this quote from an academic from a university in Sydney, Australia, Cameron Tonkin-Wise, in one of his publications. And I will move this a little bit so you can see it, which says, the futures we are getting hardly seem like the one we explicitly decide on, but they are more like the method of ones we are drifting unwittingly and mistakenly into. In other words, we are not being proactive in constructing the future that we want to be reaching or that we envision, but we are basically having a present from a future that we did not construct. It's like if the future is dragging us. And giving you this global context, now I want to briefly explain the circular economy and the context that the circular economy is at, which is compared with the context that I previously gave in the slides. And for those that are not familiar with the term of circular economy, there are many definitions, but the definition that is most well known is from the Ellen MacArthur Foundation, which says that it's an economic paradigm that aims to decouple growth from the consumption of finite resources. Now, the circular economy has also its challenges, and I want to give you two. This first example is related with materials. The circular economy is pushing for bio-based materials. However, if you analyze most of these bio-based materials with life cycle assessments, they demonstrate that compared to traditional materials, they perform poorly from an energy and resource standpoint. What I want to emphasize here is that if the circular economy is not thorough on the materials or the initiative that it's promoting, then we could end up having worse performance than the materials that we want to replace. And this is a second example related with renewable energy. As we know, the circular economy promotes an economy that should be powered by renewable energy. And in this case, on onshore and offshore wind, and in the particular case of wind turbines, unfortunately, it's an industry that is generating high and chronic levels of waste with that particular component of the wind turbine blades. So on the photo on the right-hand side on the top, you see landfills of wind turbine blades. And on the bottom, not as sad as the first photo, but still a consequence of a non-circular design, we see a playground made with wind turbine blades. So with these two examples, metaphorically speaking, and this is one of the quotes that I use in my dissertation, imagine that the circular economy is an explorer that is setting a night exploration to cross a forest, but he's doing that exploration without any torch or light. And this is why I want to introduce the concept of foresight. And foresight, just as I define the circular economy, I want to briefly define foresight, also many definitions, but one of the most well-known is from one of the most prolific foresight authors. His name is Sohail Inayatullah, and he defined foresight as the systematic study of the probable, the possible, and the preferable futures, and the needs that underlie each future. During my 4-year research and during the literature review on the first year, what I found is that both disciplines, circular economy on one hand and foresight, don't talk to each other. And the evidence of this lack of communication is by the number of publications that I analyzed, more than 300, where just a couple of papers combine both theoretical backgrounds and principles. And that's a big gap that I wanted to bridge during my research. And I use this photo to emphasize that foresight as a discipline can be that light to the circular economy discipline to try to cross that forest with a higher likelihood of success. So what are the big contributions of foresight in a nutshell? The first one is how the concept of the future changes. Foresight proposes that the future is seen rather as a time to prepare for, use the future as a space for creation. And that's why the concept of possible, plausible, preferable, or probable future takes place. So we don't see the future now unidimensional or linear, but we see the future as many probable futures. And then based on that conceptual understanding, we can create a preferred future and then the actions that can take us there. And this is a diagram from a publication from Joseph Boros, another prolific author of foresight, that graphically explains where the foresight element comes within any design or a strategy. And it's basically and let's imagine any type of project, but as an example, let's use a building project. Once we have the inputs, then the invitation of foresight is to start questioning ourselves what seems to be happening, what is really happening, and what may happen. And then that foresight should be used in the analysis, in the interpretation, and in the prospection. So the outputs and the strategy are more solid and help us to understand what we may need to do and how we will do it. So now I want to introduce the circular futures approach. This is the approach that I developed during my thesis. The circular futures approach, as you can see in the left-hand side, is a systematic process. And by systematic, I mean that it has an order. It has a first step, a second step, as you can see in the right-hand side, with 7 steps from left to right, top to bottom. So we start with surveying, then with mapping, then with exploring, cruising, encountering, landing, and transforming. And this process aims to assist organizations in shaping a decided and sustainable future, which is aligned with circular economy principles, but specifically through the use of foresight methods. Now, each of these 7 steps has many activities and many methods of foresight and a combination of circular futures elements and circular economy principles, but I want to mention just a few. So what we can see in this slide is 8 examples of foresight methods that are embedded in the previous 7 stages of the circular futures approach. And I titled this slide as a toolbox because that's exactly how I want the circular futures approach to be identified by those that want to implement it or use it. That depending on the challenge that the individuals or groups are facing, then they can use certain of these tools. You can see, and I will use just because the time is limited, 4 examples out of these 8, and I will explain them briefly. The Pollack game is a very well-known foresight method named after Fred Pollack, one of the founders of the foresight as a discipline, or considered one of the fathers of foresight. And it helps individuals that are working in a group to understand the differences they have in terms of how do each individual stand toward the future. And it's usually through 2 axes. If they are optimistic or pessimistic, and if they feel they can influence or not the future. This is one of the initial activities of the approach because it helps understand within a group the different perspectives that we have. Then the second method that I want to explain, it's next to the Pollack game, is the circular think from the future. This is a game that we adapted. The original game comes from Foresight and it's just called the Think from the Future and it's available online. But what we added was the circular title because rather than just having 4 sets of cards, you can see in the image, we added 2 additional set of cards. And these 2 additional set of cards are 1 focus on circular business models and the second one focus on circular design principles. And what we ask the participants through the cards that they get randomly is to design a thing from the future. But that thing from the future needs to be aligned to circular business models and circular design practices that they get out of luck during this exercise. This game helps the individual to start thinking about the future. And one of the cards is key because one card can say that they need to design a thing from the future, assuming that the future is in 5 years. But then another of the participants can get a card that says that he needs to design a thing based in 100 years. So they start to understand that according with the range of time, the challenge can be greater. Then we use, and this is one of the approaches or diagrams coming from the circular economy as a discipline, the butterfly diagram. So we help them using this very well-known diagram within the circular economy field. What are the flows in a circular challenge? And also how close we are or not with the user or with the consumer of the thing that we want to produce. And lastly, the example on the bottom right, backcasting, is a very powerful foresight method that differently to planning, where you start from the present toward the future. In this foresight method, you start from the future that you define, and then you work your way backwards, defining what needs to happen, let's say 6 or 1 year before your preferred future, and then you work your way background. If you define your future in 15 years, then you have 15 years that you need to map from the future to the present. And then you can define in different areas. So for example, if you're working on an organization, what it needs to be happening financially, or from a human resource point of view, or in terms of materials. So this can be applicable or translated to any type of project. And yeah, this is in a nutshell what is the circular futures approach. I will be happy to share this presentation for those that are interested, and we also publish an academic publication that explains step by step the approach, and also my thesis is publicly available, where I share also facilitation techniques based on the experience that I had. So the idea is that this approach can be applied by someone that doesn't even have an understanding of what is foresight. But the thesis, I will say that is strong enough to be able to explain you how to implement it. Thank you very much.
Thank you, Professors Justo, Mustafa, Ricardo, for sharing their experience and findings with us today. So you have given us a lot of food for thought. Now we have about 10 minutes for questions from the audience. If you have a question, please raise your hand and wait for the microphone before speaking so that the people online can see us. And I would like to invite Mustafa Şahmaran to the stage, please, so that So, if you have a question, please raise your hand. If not, I will start the question session. All right, seems like we have a lunch after the lunch issue. So, I would like to ask all the presenters a basic question. So, buildings involve massive embodied energy, and can true circularity ever be achieved? Can true circularity ever be achieved when the initial carbon investment is so high, even if the materials are recycled?
I think if the materials are recycled, especially, for example, my specialist coming from the carbon cement compound, if we eliminate the separated all service life of this project from the beginning of the completion of the construction and the end of the service life. I think if we recycle all the metals, I think it is good for the embodied energy because we start the use of the waste material, which reduce the energy consumption and at the same time reduce the CO2 emission. But if you consider the service life, I think it's not possible to reduce the embodied energy with the use of just recycled metals. We need to find some other solutions to consider the service life of this project.
Thank you for your answer. I see that in the Zoom. A few questions, so I'm going to repeat for them. Buildings involve massive embodied energy, and can true circularity ever be achieved when the initial carbon investment is so high, even if materials are recycled? Professor Navarro, could you hear us this time?
I don't know if I understood well, but you said even if materials are recycled, do you mean by that's the best way we should approach circularity?
So, but what I mean is, when we already start, we start with a big carbon deficit already. So I think the true circularity will be possible maybe in a distant future, because like we already built in an unsustainable way. And at this point, we are ameliorating the effects of the past, I believe. Like, this is like a more regenerative approach. Then maybe about 100 years later, maybe we can see truly do circular design and circular architecture.
Yeah. So, okay, I'll just try to maybe give my view on that, and then the speakers could add on. So I think when we talk about circularity, of course, the majority of CO2 is in the process of producing manufacturing materials. And that means that if we go to recycling, that we will be confronting the same process. And so we still don't have really green energy to produce those materials, renewable energy. And we saw the examples of what's happening with windmills at this stage. So the focus, as I understood it also from the European Commission, is we try to reuse as much as possible first. And there's also a focus like don't demolish but transform. So just trying to answer the question how to come to this circularity. That this happening would be, let's say, the last thing to do, but not the first last thing yet, obviously. So actually that's what I wanted to clarify. I thought that in your question you were proposing that recycling would be the only option now, but that's not the only option we are dealing with. So there's still some capacity in buildings to use capacity. And these examples, so this is a really great example of what you showed, how to recycle bricks and concrete and make new materials out of that. And when you have this disaster, you have, and that is like the first thing to do. You can't use any parts because they are all smashed. So that's quite the most effective thing to do. Going beyond the earthquake situations, there are some examples of cutting technologies which have been tested in EU, where concrete buildings have been cut in 3D units and examples and other examples. So I just wanted to put some more light on recycling, and that's not where we want to go, but in this situation, that is the most effective that you can have this.
There was still fighting the questions yes, please.
When we say the circularity in the built environment, we need to consider three different levels: micro, meso, and macro. What we were achieving, we did something at micro levels to develop the materials by using demolition waste or different type of industrial waste, whatever. But in the macro levels, one of the solutions that we consider is to develop some demand structures, or we need to develop some structures which has a good insulation in terms of heat or sound or other properties. But we also need to consider at macro levels to make this case by considering the circularity. At that time, if we consider these levels at the same time, there are some helix structures, some interaction to each other, only at that time we will be successful to, how can I say, to apply the circular economic concept with them.
So now I would like to give the word to the online presenters. They have been presented the questions. They have the first question now. Would you like to respond, Professor Navarro?
Yes, thank you. I have now 3 questions in the chat. I don't know, well, all of them are very well connected. So perhaps I can give you my view on the 3 of them and give the turn to the rest of the speakers. Well, let me say that we are talking about circular economy, but we cannot forget that circular economy is a paradigm hanging on sustainability. So when this reflection is because one of the question is critic with the circular design, because sometimes the focus is on the ecology or environmental aspects, instead of having also social aspect in the hands and dealing with them. So we need to, in my view, we need to arrive to this circular design from a sustainable perspective. And it's a question always of balancing all the aspects, arriving to the problem. In this case, is a construction design, architectural design, and we are not going very far if we are only considering this ecological aspect without prioritizing the needed balance between the social, economic also, because don't forget that the project need to be profitable. If not, we are doing nothing, and also with ecological aspects. So it's a question of balancing all of these different approach at the same time. It's a holistic approach at the same time. So starting from this consideration, yes, I agree that we are having a lot of examples that are just making up projects, given them greenwashing varnish, just to make the message more understandable for the society needs at this moment, and is a question of being honest, of having also introducing ethics in the way of acting in this construction sector is especially complicated regarding this type of issues. You know what I mean is the same all over the world, but it's a question of working on that, working on the balance of the different aspects to be considered and to have a sustainable result, and also considering ethics and the aspect related to an honest approach to the project. If you go, let me say that if you go to the general principles of sustainable construction, which are defined in an ISO standard a lot of years ago, they are talking about ethics, and they are talking about honesty in referring to the sustainable construction, which is something that perhaps people can be surprised about that, but it's a basic question to produce sustainable results.
Presentation as well, systems thinking, multi-scalar thinking, the balancing act, and ethics of circularity is also becoming very important in these practices. And Professor Rodriguez, would you like to respond on these questions?
Yes, absolutely. To add to what has been discussed, my contribution is focused on, let's be realistic with the concept of circular economy, that being 100% circular is not realistic. So what we need to do is set clear goals, and that's why the current circularity metrics on how circular are cities, or how circular is the world, which doesn't go up to 10%, are good indicators of what we should aim to accomplish in the short term or in the middle term. So that's something that I think we should emphasize, that the circular economy is a paradigm, but also long-term oriented, and that the discipline as such is still in its infancy. And as I explained, during my research, I found a gap that it doesn't consider foresight, but there may be many other gaps. So therefore, circular economy as a discipline should be very open to other disciplines to get its contributions from. So that's with regards to the first question. Then the second question on what it's prioritizing, the environment or the economic or social. My answer to that is that the circular economy initially has influence from 8 schools of thought, one being biomimicry, for example. But then there's one that is usually neglected, and I believe this is the one that contributes more to the social aspect, which is the blue economy. And the blue economy is the only school of thought that the circular economy get inspiration from, which the aim is not economic or environmental, but it's actually happiness. So the pursuit of the blue economy is that humans get that. And then, of course, to reach happiness or to get closer to a state of happiness, the social aspect is crucial. So this is an invitation for professionals and for students and academics to explore how the blue economy can become more important within a circular economy transition. And then the last one on the greenwashing, I think that also explains the state of the world. So if we don't push for more ethic in the way we do businesses or in the way journalism is done, or in general our activities, then things as greenwashing will keep happening. And this is why it's very crucial to differentiate the linear economy with the circular economy in one aspect that we haven't discussed, that is the active citizenship. So in the circular economy, citizenship is active. If we see greenwashing, then as citizens, we push for that to end. And I think we can be rest assured that the new generations are very good at doing that through different cultures and different movements that are happening right now. But the invitation is to keep doing that, to keep pushing businesses, governments, and all sectors to stop greenwashing through that participation gathering groups.
These questions. So there was a question about the initial carbon investments, and then there's another question about how can actually we make circular solutions more socially just and equitable, because while focusing on circularity, now there's a paradigm shift, are we forgetting the social aspect? So that's an important question, I believe. And the second one, the last question was about how can we move beyond the greenwashing? Right now, this subject is becoming so popular. So any member to respond?
I just want to point out about the social aspect of circularity, because there is a reality that any unless it's not accepted by the communities or the people. So no matter what we do in technical terms, like try to implement circularity as a lifestyle, if it's not accepted by the society, then there's no way that it will. And the other aspect is, well, there's only one money in the world. I'm quite sure that circularity works. So we need to change the paradigm shift in our values. Because in terms of like making business in the society and everything, because the earth is slicing in from our hands. So change of the values and putting that into society is the only two things that I believe will make towards circularity. Otherwise, it's a very nice research.
Well said. Anybody else want to add to these wonderful words? So if there are no other comments, I would like to adjourn this session. I'm Burak Pak, and thanks for joining us.